Hi, everyone. Welcome back to our Industrial Control Systems Cybersecurity series. My name is Tvisha and I'm a product manager in Cloud and AI Security. And here with me, I have my colleague, Joel.
Hi everyone, my name is Joel. I am a program manager within Cloud Cybersecurity. I deal with a lot with community and content work.
Awesome. So today we're going to be talking about OT industrial devices. So these are critical devices that are part of industrial control systems, and they are high priority targets for cyber attacks in these environments. So we try to create an aggregate of which systems are the most important across a variety of industrial control systems, including data centers, manufacturing plants, factories, other utility facilities, etc. So most industrial control systems follow the Purdue model. And today we're going to be focusing on the first few levels of the Purdue model. We're going to be talking about sensors, PLCs, HMIs, SCADA, DCS systems, etc. So Joel, can you get started on which systems are the most important in the industrial control environments?
Yeah, definitely. We'll start off with SCADA, which can be boiled down to monitoring and control of your system. So the main, I guess you can call it, purpose of this would be you have all these distributed devices and individual control loops within your facility. You want a central location where you can be like, hey, let's monitor all this data and let's, if possible, control what's going on in our facility.
Awesome. Are there any other control systems in the ICS environment?
Yeah, and I think the second one we can touch on would be DCS. As it stands for in the name, is distributed. I like to kind of use the framework of thinking of it as nodes. So autonomous, very decentralized individual loops with nobody really telling it what to do. And I think this framework, this system is used a lot for use cases that require high reliability, security, and availability. So things that you do not want going down for any reason. The reason for this is, say one or part of the system goes down, these things, while they do talk to each other, they're connected. They're not reliant on each other for, operation. And I think something that's also important to point out is a lot of the systems that exist are a hybrid mix of these two. So very rarely you would see purely SCADA, purely DCS. It'll be some combination, whatever makes most sense for the business that you have.
That's really cool. Do these systems also control other aspects of the ICS environment, like the temperature, pressure, etc., or is that a different system?
Yeah, so for the actual operational, like day-to-day life within these facilities, we have the BAS system. You can think of it as like a building management where you have your HVAC, your lighting, plumbing, badging, security, things of anything that pretty much helps run the facility. And you can go through the BAS system, and this will enable it to be run more efficiently because you have all these controllers, these sensors, and instead of having technicians in there manually editing stuff, you have all these things being able to control the actual, operations and day to day.
Very cool.
Yeah. So now that we kind of covered the overall systems, we can touch a little bit on the individual components and devices that make up the broader OT environments. So the first one is the PLC, the programmable logic controllers. These things, the way I like to think of them is if you have some sort of business need within your facility, say you're a manufacturing plant and you're building cars or you're bottling soda or whatever, these PLCs are specifically designed with that logic in mind. So you have those, those robot arms that put together the cars. They're controlled by PLCs, and they have specific code in there that helps, build the whatever you're trying to do. Something else that is very important to the system overall is IEDs. These intelligent electronic devices are used mostly to control the power system and make proper adjustments within the system based on the telemetry they received. So the way I like to imagine it is if you have a certain backup or something's going wrong up or downstream from these devices, they get that data and they're like, hey, let's edit it. Let's do something to help alleviate whatever problem we're seeing. This is closely related to safety controllers. So say they get these devices receive telemetry and there's something going wrong. The example that we brought up in a previous video was in a data center scenario where you build up a lot of pressure within a room. Say the safety controller has been compromised. The pressure builds up eventually where the walls pretty much blow out and it becomes effectively a bomb. So that's what safety controllers are meant to prevent, where they see something's going south really quickly. They're like, hey, let's shut it down. Let's get our technicians, our engineers in there and try to figure out how to fix this. And then the final thing I would like to talk about as well would be microcontrollers. These are like your old school kind of like spy movie things where like they have the pad and all that stuff with the numbers and buttons and whatnot. These are very localized devices meant to control very small aspects of the larger control loop or in the larger system. So something we do want to bring up is that even though each individual piece is very critical and they all have their own logic and code and all that stuff within them, they all talk to each other like I alluded to. There's telemetry going between them. There's info, data, and the main concern from a cybersecurity perspective is, say, a technician or even a malicious actor comes in, plug in a USB, even not on purpose, but say that USB has something bad on it. It has some malicious code that can alter one of these devices or possibly take them down. That's where the threat comes in, where these devices, since they're all connected and since they're connected to the greater system, once a thread is inside, it can move horizontally, it can move vertically, and possibly affect entire facilities. That's our main concern here with what we're really focused on in the OT space.
Yeah, that was awesome. Thank you so much, Joel. You made a lot of really good points about how attackers can enter the environment through some of these devices and then move laterally and pretty much control everything within the environment. That's pretty scary. I learned a lot through this. Thanks a lot. And we'll see you next time.